There we are. We are live again. So I'm here with Cyril Prushko, and he's going to talk about his experiences with LiveCode in education. I'm just going to check that everybody is joining. We've got 49 people live, and that you can see and hear us. And so if you can just, before we get going, let's just make sure we get some messages in the chat that they can see us. Yep, Mark can, and Brian can hear us. And Sandy is there. I think we're good. I think we're good to go. All right then, Cyril, so it's all over to you. Let's hear what you've got for us.
Okay, my name is Cyril Prushko, and I am currently a retired teacher. But I'm going to share with you some of the materials I've developed over the years and maybe helping you with projects. If you're not a teacher, you may find some fun projects to tackle yourself. Some of the relevant projects we've done was writing your own chatbot, like Siri or Google Now, data mining, modifying pixels and photographs, taking people in and out of photographs, and that. And it worked it's very effective in a classroom. So I'm working from this. Okay, what I'm going to do is first show some resources for teachers, because I saw in an earlier session somebody wanted to know if Kevin had any information on marketing materials for trying to get LiveCode adopted in your school. So I'm going to share a few of those with you. And then we're going to go through some really simple starter projects. The first time with students that may have no knowledge of computers or experience programming. Then we're going to look at a range of projects, including games, programs, and apps, and then do more involved projects like the digital magic, chatbot, and big data. All the materials, everything I'm covering today is going to be available. Why project-based? It plays to LiveCode's strengths. Typically, in teaching a language, you go through the pieces of a language. You go through naming variables, then you go through if statements, and then if-else statements, then nested if statements. Then you start doing some programming. I like to start out the first day and let's start writing a program. You'll learn as you go along. And LiveCode's strengths are being able to put together a program with a nice user interface. And this is a lot based in the real world. I mean, sometimes you don't have time to study a language, especially if it's a new language, and your boss just says, get it done, do this project. So you're learning on a project basis rather than going to a class for 6 months or going through tutorials. I also try to make it fun, interesting, and engaging, because this is an effective way to learn it by using it. I know in some language courses, they have immersive languages where you learn a language just by talking it all the time. And then this also, LiveCode allows you to do teaching of soft skills, like problem solving, analytical thinking, creativity, not just coding. You don't spend time teaching the language, you're teaching computer science and computational thinking. I have my notes there, that's what you're seeing. This is a learning pyramid, just a little diagram to show that most of learning occurs when you're teaching or practicing. And this is along the idea of doing projects and working with others, teamwork. Okay, in real world, you have a project to finish, and you have to figure it out by yourself. You don't have the time to access or attend classes or learn a language from start to finish. So you learn by reading manuals, looking at other people's code, and trial and error. And sometimes you have time constraints and no resident expert to help you. You just have a job to get done. So this is the way my classroom works. We start out together on a simple program. I show them a few things because they're starting with nothing. So I show them a few simple statements. I make sure everyone does it together and is successful. So you start simple. Then you give them a simple modification or another example and see if they understood it well enough to continue on their own. And then finally, you give them a choice of a project or a program that allows them to even make it their own. Okay, I believe real learning occurs by doing. So I try to teach as little as possible. You just wait until the need arises. I mean, you could go through if statements, if then else, nested ifs, the advantages, the disadvantages. But when you really learn it is when you run into the problem and you learn on your own. And also encourage them to research it themselves, make available other samples of code. Even if you give them the answer and you tell them make it a little bit different. We all know it's not easy picking up code from somebody else and putting it into your own program. So they do learn that way. Okay, so basically, we did a program a week. I mean, the harder problems like the artificial intelligence, we took 2 weeks. But basically on day one, I project on the LCD projector. We all write a simple program or learn something together. Then day 2, I said, okay, here's some twists to it, or here's something else you can add. Let's all do it. Not together, but let's go over it. And then the rest of the week, they do a project or a game, an app, or something of their very own. Okay, for getting started, I put together slides from other presentations that might help you in selling LiveCode to your colleagues, to your administrators, to your school officials, or even selling it to the students because they haven't heard from it. They want to learn the big boy languages, Java and Python and that. Also I pulled this workshop from lessons from my classes and from a workshop I just did recently. Okay, so this is what we're going to cover. We're not going to, you'll see. If you want to access any of these materials right now, I threw them up on a web page here. The links and that. So if you can either sit back and watch, or you can surf on your own. So let me show you the teacher materials I have. Okay, I put together, as I said, a number of slides to help other teachers. When you're talking to people, what can we do with LiveCode? Here's some examples. This first one is an example of what they get done in the first week. You can do live action games, drag and drop games. You could have them do a school site, write little programs, put all their links together. Here's an example of a base chatbot, animal wizard, a tip calculator. I also have more links for cards and that. So if you want to show them what you can do with LiveCode and say, match that with Python or Java the first month of school. All right, then I show you, well, if your administrator asks who has used LiveCode, you can use this as an example. Our school is even though it's a science and tech school, it's only 25% science and tech students. The rest are neighborhood kids from inner city Washington, D.C. So we're not dealing with Sheldons in the world. Our class makeup, my classes are 50% female. So this mode of teaching appears to attract females. 4 years ago when I started doing this, our enrollment was 24. We went up to 345 students. We had actually 485 students request this intro course with LiveCode and Python, and we had to turn many of them away. And so the growth is there. It's now the most popular class in the school. Congress listed our school as one of the top high school schools in app development. Students have won awards globally. And this website that I use, that I put together, is in use by 25,000 students a year in 80 countries. And that's according to Google Analytics. So, classroom. So this is a set of slides you can show principles or that. Doing it with LiveCode. Reasons for using LifeCode: it's easy. These, you should be familiar with these. These are selling points, marketing points, advantages of running LifeCode. What are some of the things you can do? Real life skills. You can spend more time on real life skills. You're not wasting your time on hunting missing semicolons and indentations and things like that with other languages. Plenty of help available. Okay, next group of slides. I show the basics, and this just shows how easy it is to get started. The environment. You have the edit bar and the toolbar. Toolbar contains the tools, the objects that you use. And then it's just a matter of designing your UI, picking the attributes, the properties, and then attaching code to your objects. And you end up with adding graphics. Then I have sample games using buttons. So these are all just examples. If you expand the keynote presentation, it shows you the code. And you can show anyone the code is not that difficult, as you know. The nice thing about doing projects is that it's easy to show results. Okay, so those are the slides. They're there. You're welcome to use them anytime you want. Okay, to the other site that I put up here. Since I retired, one school wanted to, they asked me to come in and help them get a computer club started or a computer department started. They were having a hard time. They tried offering a course and only 3 students signed up for it. So I put together this. We had a 4-day period. This was a challenge to see if I did with projects. In 4 days, could I teach them enough that they could write all sorts of projects? And this is what came out of it. So if we, let's see, let me switch to, this is the workshop. Are you seeing this?
Yes, we're seeing it. Yes, don't worry. Following along.
Are you seeing the... All right, is everyone still there?
Yep, we're here. Don't worry, we haven't lost you.
Okay, this is the workshop. The first day, we did the first program. And these are screenshots, start piece by piece. You start up LiveCode, and that's what you see. Then you start up a new application by clicking on File, New Stack, Default Size. Okay, if you notice, the stack is untitled, so we want to give it a name. So you click on Object, Stack Inspector. That brings up the inspector with all the attributes, the properties. Change the name to hello. And if you notice, it changes up top and it changes on your stack. And then we file save it. And I put it in my desktop. And then we click on a button icon. Any one of those buttons will do. Put it on the card. Open up, click on the inspector. Open up, click on the button. Give it a name of hello. And if you really want to be fancy, you can click on the A and change the font, the text size and that. Then to add code, you click on the script button. It brings up the code window or the handler list. Click on mouse up. Add the code, answer, hello there. Now notice the button is yellow. You click apply and it'll tell you whether you have any errors, and it'll turn green or red, depending on whether you have errors. Then you click on the run button and you have a working project. So then I immediately start tweaking that. You talk to them about the answer command and you say, okay, this is what we did. Hello. And this is in a one screen shot what we did. I did this on the second day because the first day we did the install. And then we run it and it says hello. You can make the button say your own. Here, it only gives you OK. That's the default button. If you want to change it, you could ask it a question like, do you want to continue, and make the button say yes or no. So let's all do that. And I have the students do that. Then I introduce the ask button where it actually pops up a name, a text box for you to type a name in. And we show it, and then we take it one step for. So I'm working on the screen. They're doing it on their computers. I may take a break and walk around to talk with them. Make sure everyone's on the same task. And then the project is write a, okay, and I add some more if they want to. For the ones who get finished and want to learn more, they can move ahead. And I also show them if statement. Okay, let's change our code to read this. What is your name? Put it into the name. Answer, hello, the name. What gender are you, with male or female? Now we want to give a different greeting for them based on whether they're a man or a woman. So we use an if statement. It allows us to make a choice. If it is male, then answer, actually I've simplified this. I just ask, what gender are you, with male or female? And then I say, if it is male, answer Mr. and then the name. This seems like a lot, but as they do it, they have no problem understanding it. If you have a more advanced class, you can go ahead and talk to them about if statements, nested if statements, and else if statements. But for practical purposes, just use this form through all your examples from now on. And then the project for this was on day 2. If you span to another day, I often start with another example, like riddles. And since we're on the first couple of days, keep it simple. Just step them through it so everybody does it. Name the stack, save it, drag over a button, click the inspector, give it a name, make it look nice, add a shadow, add a background fill, and then, or you can add backgrounds. And then for the code, you could step through this or just have them put it in themselves. Ask what starts with a T, has a T in it, and ends with a T. If it contains teapot, then answer good job, you got it right. Else answer no, it's a teapot. So this keeps things nice and simple. So the next step is write your own project. Okay. And I think next I take you to projects. All right, for the rest of the week, then they can pick one of these programs, projects. And, you know, something like a greeting program, have them ask a student what grade you're in and giving an answer. If let's say you were a 10th grader, you ask them a question. If they say 9th, you say, you know, give them a demeaning answer. Get out of my way, underling. For a 10th grader, say welcome, fellow 10th grader, and so forth. This gives them practice to using the if and then else. Some of them like to be creative. Fortune-telling program. And you can get some really creative, have some fun games that they enjoy. Talk like a pirate. You put buttons on there. You have a button with, I have more detail on this, but you put on a button that says hi. And the pirate would say ahoy. And if you said, hi, friend, the resultant pirate talk would be ahoy, matey. So are we still with everybody?
Yep, we're still here, I do believe. I'm certainly still here, and I don't see any evidence that nobody else is. So, yep, carry on.
Are we still connected?
Yep, we are connected.
Okay, good. I'll continue. Thank you. Alrighty then. Cards, books, you could have them. This is an example of doing interactive books. You can start out showing them how to make more than one card and to go from card 1 to card 2. And while you're at it, you show them how to add visual effects. And then the next step would be to make a greeting card. So I supply responses and have them make a greeting card. If it's near Halloween, have them make Happy Halloween cards. Interactive cards that switch. So this would be the project. So we're talking, this is the first week or two. And I think I have examples. One girl found an animated GIF, and so she had it move across. It looked like Snoop Dogg was dancing across her card. They get very creative, and they come up with these ideas. Most of these ideas, these examples, and lessons are a result of students coming up with them as projects and wanting to do them. All right, Magic Math, 1 week. Show them fields on a screen where you make a little math program that adds and multiplies numbers. And this is what it's going to look like. And you, again, step through it. Drag over a label and drag over. Then in the contents, put the text, format it a little bit larger, and you drag over a text entry box. You have them size it a little bit larger and set the font larger. Then hold down the control key and drag copies off for it. So you make copies, and then you just hop from field to field, changing it so that it reads number 1, number 2, sum, and product, the product. And then you go and name these fields. So you're going to name this num1, num2, or x and y. Name this x plus y and this x times y. And have a done button. And then when they press the done button, there's the code for it. And you can read it. It does make sense. Okay, and then the next step, after you show them this, would be, let's do a project. So if I click on this link and go to greeting card, or not greetings cards, I'm sorry. If I go to projects, these are projects that the kids came up with. Someone figured out the perimeter of a rectangle. Someone did a geometry calculator for a rectangle and parallelogram. Calculators, a change calculator, a sales tax that calculates the sales tax, a tip calculator, Euro calculator. Some of them get out of hand and really go and do fancy sites. Age calculator, height, whatever you could think of, whatever they come up with. That someone did a Caesar cipher to encode a message. Lucky number generator. So they get very creative. And, you know, as problems come up, we tackle them, but I keep teaching to a minimum. Next step, let's see, how are we doing for time? Games.
You've got 13 minutes.
Here is my site on game programming. And I did not do all of these. These just happen from students doing things on their own or ideas we come up with. But I show them how to use the mouse. One type of mouse, using a mouse, is for educational games where you drag and drop. So you show them the code. The code for an educational game is really quite simple. On mouse down, grab me. On mouse up, you want to answer correct. Now you could, if you have the time, you could turn this into a question. Before you talk about the code, you say, okay, what do we want to do when they let go of it? If it's there, we answer correct. Good job. If it's not there, do we want to answer bad? Or why don't we just move it back? I show them some games from the Apple Store that they can relate to. So the goal for them is to make a game, drag and drop. And look at that. Someone did an organic chemistry quiz. So it doesn't have to be simple. It can be almost on anything they want to do. Do we have any questions? I'm going pretty fast and I'm doing all the talking. Shall I continue?
Well, I'm not seeing much in the way of questions, so I guess, yeah, carry on.
Okay, I'll continue then. I see everyone's still with me right now. All right, in apps, on this, in one day, I took one day to show them how to make games and one day of making apps. For apps, clicking on the workshop apps, these are what we did day 4. I showed them how to make kick-off applications in their program and open up a browser. Then we showed how to do a school app, and they had to do their own school app. An example of creating, there are sites that you visit regularly every day. And you can look at, it's nice to have this in a little place where you can access it easily instead of having to go to other means of getting to those sites. The code is very simple. Basically, it's launch URL Gmail. And to go to your school link, you go to HTTPS, launch that URL. You can launch that. So launch URL opens a website. It also opens files. You can open up a file on your computer. So if you have saved the school bell schedule, what time each period ends, you can pull that up anytime you want. You can open up a file. You can even text or call people from within your app by using the launch URL. You can open up documents. There's how you do a telephone. There's how you do text messages. So, okay, I'm going to jump ahead. You can look at the other pages yourself and look at some of the projects. They're very interesting. There's some really interesting ones. Okay, for the chatbot, what we did here is basically write our own Siri. And I think I uploaded artificial intelligence. Chatterbots is basically what Siri is. If you go onto websites, they don't have live people. When you click on that chat button, like Anna is IKEA's chatbot. When you click to chat with somebody, you're talking to Anna. Anna's not a live person. It's a program. So let's learn about chatbots. The first link takes you to some chatbot sites where you can talk to Captain Kirk. If some of you may remember Eliza, the psychiatrist way back in the old days. Then we start with a starter chatbot. Our classes are 45 minutes a day. So I keep it very fast. Okay, to doing a chatbot, I give them the working code. But I do explain what is part. We have a log and input. You type your answer, you type your question or whatever you want to say, and then your chatbot will answer you. Okay, and then I document the code. We have two global variables, input and response. You type something and your program figures out the response. Okay, so when we open the card, you put hello, let's talk, and you select that line. Okay, when they hit the enter key, type something and hit enter, you get the response. And then we're back to the if statements. If the input contains mother, then put this in the response and give them that answer. So we have code here. If no, then you say, why so negative? If they say mother or father or sister or brother, you say, tell me more about your family. And when you get down to here, if you don't recognize anything, we get a random response, and that comes down here, and that picks a number between 1 and 4 and gives you one of these 4 answers. Interesting. Tell me more. Do you really think so? You don't say. So the first job is to make your chatbot smarter. Have some more keywords like hungry and food and that, and you add that code. I always show the code in red. So they start doing their own chatbot. And we talk about this. Now, if you have an advanced class, this is perfect for take them. You can see that after you get so many words, it starts getting very tedious doing this code. So what you start doing is we can look for words. It's the average. This is a good place to introduce lists. And in the next logical space, if you want to tackle arrays, where you could really find the word instantly instead of looking through a list. Students did projects. One girl did hers that understood only Spanish. A young man did his on street talk. I had to get students to help me test it. A girl made hers a recycling expert. It knew every question you could ask it about recycling. Okay, big data. These are buzzwords that students may have heard and that. And here, I ask them, every year, they come out with the top 10 girls' names and boys' names. So where is your name in the list? Is your name one of the top 10 students' names that they pick for boys or girls? Cyril is way down. Where is mine? So this big data, we download the names of everyone that was born the year you were. The government has, the Census Bureau and Social Security gives you access to those names. So the year I was born, 27 million people were born. So I download 27 million names, and we work with those. Now, this is not so hard as you think. You create a button and a field, and you load the field. And the file has, I don't know, their name, the first name, whether it's male or female, and I think that's its location in the list. So then we go and open up the message book and say, find Sam in field names. And it finds it. We tackle the sort command. We do this in class. And this goes much faster than you think. It seems like we're covering a lot of material in such a short time, but they really take to it. Then the project for the week is I give them a set of data, and I tell them to come up with their own, pick any set of data and make their own. And these are what some of them came up with. One student took all the summer camps and allowed you to look up summer camps, facts about all the states in the United States, workforces and labor and how many people are employed, unemployed, average hourly wage. Some of them got very elaborate in what they did. One person looked up animal licenses. You should see some of the animals that have licenses in Maryland. Cats and that. Federal spending. Anything the data. And digital magic, we work on doing going through a photograph pixel by pixel. Now this is especially, it's more complicated in LiveCode than it is in other languages. Unfortunately, but it can be done. This is one where you give the students a lot of the code and they modify it. Basically, you go through all the pixels and you get the pixel and then you break it apart into the colors. The alpha, the red, the green, and the blue. And the first thing that we do is I give them a red X and tell them to change it to white. Write the code to change all the red pixels to white. And then we go and we do changing the colors of pictures. And eventually we work up to taking people out of pictures and putting people into pictures. The code, like I said, this is the worst part of LifeCode. I have the same lessons in Python and Java. So if students are really serious, I can show them. In most cases, the code is the same in all languages because they always have the same constructs, if, then, else, things like that. But this part, they do see the difference. All right, and then if you want to show them something simple, Animal Wizard. If they want to know how do we work with lists, especially when you start writing apps like to-do lists or anything that you would do a list. This is an Animal Wizard program, and basically it has a file. So the students learn how to read and write a file. And the code, we explain the code. We keep a global variable. And then we get the file, read the file, ask what letter does it start with. We put a letter and put false into found, and then we go through our list. If the first letters match, we ask it, is it the So if you typed alligator, it'll pick up the first one, which might be ant, and say, is it an ant? And you say no. Then it keeps going through all the A's, and if it doesn't find it, it adds the new animal at the end and writes out the file. So it gets smarter as you go along. Well, this is perfect for a lot of programs. So you can give them a program to make a to-do list, or a shopping list, or a homework, or a program to write notes. So any questions? I went through a lot there.
It looks like Ralph wants to know what the best way is to sell this to his local high school.
So I threw a lot of material about it, but basically it's the same. Doing projects is what's exciting, especially projects that run on their phones or their computers. That's what makes it exciting. It's relevant. It's fun. And I found by experimenting, well, first of all, because of doing the starting out with LifeCode, I didn't know LifeCode. So I learned along with them. And as they came up with questions or came up with projects ideas, I added it to this list. That's why this has grown so much. But they like the idea of being able to do things for their computer. And it works not only for the really good students, but my principal threw me a class of students that were about to fail. They were dropouts. They did nothing in school. They got into trouble and that. And this was the only class that motivated them not only to stay in school, but to do some work. And I always used to laugh because at times there'd be policemen outside my door. And they were looking for someone, or the administration was looking for a student. And they would know that they would be in this class. When we switched to Python, I lost a few of them. So I think it's the relevance in this. I use the same in Java and when I taught Python, and the project idea works. The less you give them, and often is the better.
Well, that was really, really awesome, Cyril. I really enjoyed that. So, yeah.
Did you remember Eliza?
I've heard the word. I'm not sure I ever encountered it.
Eliza, it was a big thing. You could type on a calculator on a computer, and it was a psychiatrist.
Yeah, yeah.
It would keep you talking. You know, you'd say, it would ask you, what's wrong? Oh, I'm a little sad. Why are you sad? Oh, I guess it's been a bad day. Why has it been a bad day? And the typical, keep you talking. In fact, artificial intelligence, every year they have a big contest. And who could write not only the best artificial intelligence program that could keep someone talking for the longest, but could answer some really weird questions. That's on one of the pages. Kids get a kick out of seeing the chatbots that are out there. I mean, there are tens of thousands, hundreds of thousands of chatbots, and with faces to them and that. My students were 9th to 12th, although I've been working a little bit with middle school students, and this seems to be working with them too. With middle school students, you keep them simpler, or you give them more code. I mean, even giving them the program, and they always want to change it to something they recognize, a game they recognize. Can we make these go down instead of across the screen? You figure it out. And that works. If they want it so bad, they'll do it. They'll figure it out. And they collaborate. They learn to get along with each other. They learn to help each other. They learn to do research, which is a lot like the real world.
That's really cool. It's really cool. And by the way, in case anybody thinks that the live chat on our website is in fact a bot, I'm not a bot. I'm for real. I have actually had people ask me if I am a robot. So I'm not. But yeah, this is great stuff. This is really good. And I'm, you know, it's really good to feel that LifeCode, you know, is really enthusing these kids that were dropouts, and you know, it's maybe taking them somewhere that they mightn't have gone. So I think it's good.
And on that, my old website, where all the games and all my lessons are, I no longer have editor privileges to edit it. So, but there still are some good links. There's a page where I explain why LiveCode, especially to your colleagues who know Java and Python. I explain why LiveCode is so much better. It's because of the Boolean. It's because of the counting, starting counting, doing arrays at 1 instead of 0. I give all the technical reasons why LiveCode is so much easier to teach. And I've found that if you teach them LiveCode first, they can learn any language. Because 4 years ago, I taught Python. I used to teach C++. Then I taught Python. It was a little bit easier. We lost fewer students, but the classes got small. Then I added LiveCode at the end, and they really perked up. So the last year, I did LiveCode first. We did a semester of LiveCode. Then we did what was supposed to be a semester of Python, we did in 2 months. I used up all my lessons. So we had to, they said they want to learn Java. We did Java in 2 months. And I was starting to deal with material from the AP Java course. So the statement that LiveCode's the best language to learn in is really good because they understand the concepts. Think of it when you learn to drive a car. Do you get a stick shift where you are shifting, or do you learn to drive in an automatic? You have your children learn in an automatic because they're busy enough trying to concentrate on the rules and the stop signs and watching pedestrians and keeping the car on the road. They don't need to worry about clutching and on hills and stalling out. Learn the basics first. So with LiveCode, you learn the concepts and you really understand them. And then when you move on to other languages that have all sorts of weird things, like for Boolean, with LiveCode, you say, is it equal to, or you could say, is if X is 3. Whereas in Java, you've got to use 2 equal signs instead of 1 equal sign. And in Python, you can use, sometimes you use 2 equal signs and sometimes you use 3 equal signs to check for equivalence. You know, no wonder students get bored and drop out.
Yeah. Well, that's brilliant, Cyril. I'm going to have to stop you there, I think, because we are at the end of your hour.
Okay.
But that was really great. So, yeah, thank you so much.
You're welcome. And thanks for everyone for attending.
And all those materials will be available afterwards, so you can all go and poke around and see what you can make. I'm looking forward to a rash of chatbots.
Upload into LiveCode chatbot, and you could start making it your own. It's a lot of fun.
Yeah, it does. It does.
It's easy to make it talk, but it's harder to make it listen. I haven't figured out worked much on making it listen. Yeah, where it would understand spoken. All right, okay. Thank you very much.
Okay, bye-bye, everybody, and come back again in a couple of minutes when I will be introducing Ralph And he's going to tell us about Android and deploying to Android and iOS. So that's going to be interesting.
Great.
Okay.
Thank you.
Bye.
Bye.